All right, time to wrap up 4.5. So I'm counting on that you have done your classwork and your practice for examples 1 through 3 using the factor theorem with the remainder theorem, identifying positive and negative zeros, and then finding your possible rational zeros. Because we are going to tie all of that together now. And how do we use all of that to solve for x? So I have the list of steps here for you. Definitely take the time to write them out. So our first step, we're going to check the sign changes, positives and negatives. If I get I go through and I check sign changes and it's 0 positives, I don't want to try positives. I will be wasting my time if I try positives. So I would only be trying negatives. So you do want to use the sign changes to narrow it down. The P's and Q's you want to use because those are the only numbers that will be solutions. If you try 5, but that wasn't one of your possible solutions, you're never going to get the correct answer. And then we use the synthetic division with the factor theorem and the remainder theorem. So if I divide by one of my possible choices and I get 0, then that is an answer. And I'm like, yes, and I can move on and continue to find them, either by factoring or the use of the quadratic formula. Or you can keep trying numbers until you find one that works. But that can take time. So the rational zeros theorem to find all the zeros, which is this process. If I find one, then I can find the rest using its leftover factors. So let's start with sign changes. No sign change. Yes, there was a sign change. No, there wasn't a sign change. So these are your possible positives. There was one sign change. You know what that means? There is one positive solution. One. So I don't need to check other sign changes because for sure there is one. So I'm not even going to try the negatives. You're welcome to, but I'm not going to. So now I'm going to list my P's over Q's. So my P's come from the last term. So what divides? Let me rewrite this. What divides into 6? 1, 2, 3, and 6. What divides into 1? 1. So that makes it nice. So our possible solutions. Here are our possibles. P over Q. Plus or minus 1 over 1. Plus or minus 2 over 1, which is 2. Plus or minus 3 over 1, which is 3. Plus or minus 6 over 1, which is 6. So those are my possibles. But remember, because I know that there is one positive solution, I am not going to try the negatives. I'm not going to try them. There might be one that is a solution, but I'm not going to try it yet. These are the 4 that I'm going to try with synthetic division. So you pick one. And you could pick 1, you could pick 2, you could pick 3, you could pick 6. Don't pick anything other than those 4. They will not work. So to use the synthetic division, I'm going to pick 1. And this is the guess and check part. Just do this on another piece of paper, your scratch paper, and you go until you get 0 for your remainder. And if you make a mistake, oh my goodness, good luck with that because you're going to be here for days. Don't make mistakes. So I put my coefficients from each of these. 3, 2, 1, none. No missings, so I won't have zeros. 1, 2, -5, -6. Okay, so I have to go until my remainder is 0. So I drop this 1. Drop it. Multiply, I get 1. Add, I get 3. Multiply, I get 3. Add, I get -2. Multiply, I get -2. Add, I get -8. Whoops. My remainder is not 0. That means 1 is not going to work. So now I need to set this up again. But I'm going to try a different number now. I'm going to try 2. So I try 2. Set this up. This is why scratch paper is good. You can just keep going. Drop the 1. multiply, I get 2, add, I get 4, multiply, I get 8, add, I get 3, multiply, I get 6. Oh, thank you. I got 0. So I don't need to use synthetic division anymore. Since I got 0, this means that x equals 2 is a solution. That was the number I tried. I got 0. That's one of them. Now I need to find my other solutions. You could go through and keep guessing some numbers, but there won't be any more positives because there was only one possible positive. We found it. The rest will either be negative or imaginary. So how do we go through and finish this? Well, if you look at this right here, the 1, the 4, and the 3, we have already found 1x, one of them. How many were there supposed to be? Well, let's look back in the fundamental theorem of algebra. If my exponent is a 3, I should have possible 3 zeros. Possible 3 real zeros. I have found 1. How many are left? Hopefully you're saying 2. So when I'm going to rewrite 1, 4, and 3 as a polynomial. I have found 1 solution. So what is left? 2. So this is 1x squared plus 4x plus 3. I have found 1. There are 2 more. So I rewrite the 1, the 4, and the 3, and I start with the fact that there are 2 more. I don't need that 1 there, so I'm going to ignore the 1. And hopefully you guys recognize that you can factor this. What multiplies to 3? 1 times 3. So x plus 3, x plus 1 equals 0. Oh, x equals negative 3 and negative 1. And what did we find earlier? 2. There are my zeros. The tricky part that most students have every year is going from the 1, 4, 3 to the x squared plus 4x plus 3. You need to understand that we found 1 solution. That means there are 2 left. And I did division. I went through and I divided this. So what I have left needs to be refactored. And if I was using the long division, this would be x squared plus 4x plus 3. But we're doing this without the long division. You are welcome to use long division, but I don't recommend it, but you're welcome to. So that one's done. It's a long process, especially if you're like crappy guesser and you guys are picking numbers that never seem to work. So we're going to go through this again. You're going to see this several more times. So solve each equation in the real number system. So I don't care if there's imaginary solutions. I'm not finding them. I'm only going to find the real solutions. So I'm going to look at the sign changes second. Let me look at the degree. Since our degree is 4, we are looking for 4 solutions. So there might be 4 solutions. There might be 2 real, 2 imaginary. There could be no real. They could all be imaginary. There could be 4 real. So we have to make sure we go through until we find all of them, but just understand that your solution is only going to include the real ones. So I am going to look for sign changes first. Yes, 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 no. So that means there could be 3 positives. 3 or 1 positive. That's good. I don't have to do the negatives again. I would only need to do the negatives if one of my options were 0. Because what if it was 0? I don't want to go through and test if it's definitely 0. So now I know I'm only going to try positive. So let's look at our P's and Q's. What multiplies to 8? Let me change colors for this. What multiplies to 8? Or divides into 8. 1, 2, 4, and 8. And then what multiplies into 1? 1. So that's actually not so bad. So your P over Q, plus or minus 1, 2, 4, and 8. And since I know that my sign changes are 3 or 1, that's really nice. I'm only going to try the positives. So now I'm going to go into the synthetic division, and I'm going to start with 1. Check for placeholders. 4, 3, 2, 1, none. So that's good. 1, negative 1, 2, negative 4, negative 8. And remember, we go through this until we have a remainder of 0. The remainder must be 0, so we need to be careful not to make mistakes. So I drop the 1. 1 times 1 is 1. Add, I get 0. Multiply, 0. Add, I get 2. Multiply, I get 2. Add, I get negative 2. Multiply, negative 2. Oh man, that's not going to give me 0. So I need to pick another number. So I'm going to pick 2 this time. So I just start at the beginning and work my way through. So I drop the 1, multiply, I get 2, add, I get 1, multiply, I get 2, add, I get 4, multiply, I get 8, add, I get 4, multiply, I get 8. Oh, yes, okay. So now I need to rewrite this in a form that I can try and factor. So I know one of my answers is 2. So there were how many possible solutions for this one? There are 4. I have found 1. So there are 3 more. So when I start, this is x cubed plus x squared plus 4x plus 4 equals 0. So from here, you are welcome to continue to try with synthetic division and go until you get 0 again. Maybe you try 4 and you try 8. And maybe you got to try some negatives if 4 and 8 don't work. I'm going to show you a different kind of factoring here that is actually a lot easier to do. I'm going to show you what is called factor by grouping. Factor by grouping can only be done when you have an even number of terms. I want to look here and here. So I'm looking at these separately. If I look at x cubed and x squared, what do those share? They share an x squared. So if I take x squared out, I am left with x plus 1. If I look at 4x and 4, I can take a 4 out, and I am left with x plus 1. What's nice here is that they share the x plus 1. So that becomes one of my factors. X plus 1. And then what am I left with? X squared plus 4. So there's my other 2 factors. So now I need to solve this. So I have x plus 1 equals 0, which is negative 1. X squared plus 4 equals 0. X squared equals negative 4. Uh-oh, when I square root, that's imaginary. And today you guys are only finding the real solutions. So your real solutions, you have, this is 2 imaginary solutions. My real solutions were 2 and negative 1. The other 2 are imaginary, but today we're only finding the real solutions. Now, let's say that did not make any sense to you. You don't get the factor by grouping, that's fine. You don't need to use factor by grouping. So I'm going to erase all this and I'm going to show you another method instead of factor by grouping. You decide what you want to use. So I'm going to go through synthetic division again. 1, 1, 4, 4. And I go until I get 0. So I have 2 more positives left, 4 and 8. So if I put in 4, go through the multiplication. Okay, that's definitely not going to work. So now I'm going to try 8. Okay, not going to work. That's not going to give me 0. So now I need to think of something else to try. So instead of positives, I'm going to go back to my solutions and I'm going to think, oh, it might be a negative then. So now I'm going to try -1. -1, 0, 0, 4, -4. So that worked. So -1 was a solution. So I found how many solutions now? I have found x equals 2 and x equals -1. So how many do we have left? We have 2 more left. So this is x squared plus 0x plus 4, which is just x squared plus 4 equals 0. X squared equals -4. And when you square root, you get 2 imaginary. So we only had 2 real solutions. X equaled 2 and -1. All right, let's look at the next one. It's a long process, you guys. These are not short by any means. Okay, sign changes. Change the color. Okay, nope. Nope. Yes. Yes. Uh-oh. Possible positives, 2 or 0. Oh my gosh, that sucks. So there might not be any positives because of the fact that I got 0. So, oh man, what am I going to do? Well, I think I'm going to end up trying negatives then. I'll just try a bunch of different numbers. So my P's over Q's, what makes 6? 1, 2, 3, and 6. And this is just 1. So I have plus or minus 1, 2, 3, and 6. So I'm going to go through the synthetic division and I'm just going to pick a bunch of numbers. And I really think I am going to start with the negatives because that 0 there just bothers me. So I'm looking for 4 solutions. Do you remember why I'm looking for 4 solutions? What's the degree? Since our degree is 4, we're looking for 4 solutions. And some might be real, some might be imaginary. So let's start playing around with this. Whoops, 1, 4, 2, -1, and 6. There was nothing missing. Okay, let's see how good of a guesser I am going to be. I'm going to pick a negative, and I'm going to start with -1. I hope this works. -1, 3, -3, -1, 1, 0. Oh, okay, that didn't work. Let's pick another one. I'm going to try -2. -2, 2, -4, -2, 4, 3. Oh, okay. That wasn't so bad. So I only had to go through that twice. So what do I know for sure is a 0, -2. So I found 1 out of 4. So I am left with 3 more. So x cubed, 2x squared, minus 2x, plus 3. Door for trick-or-treaters. So I found one factor. So I'm going to use this and I'm going to continue through the synthetic division. So I finished at -2, so now I'm going to go -3. But I'm going to go ahead and use these ones here. So the 1, just like in the last one, the 1, the 2, the -2, and the 3. And I'm going to go until I get 0. So 1, multiply, I get -3. Add, I get -1. Multiply, I get +3. Add, I get 1. Multiply, -3, and I get 0. All right, so now I have found 2 solutions. So I found -2 and I found -3. So I'm going to now use that I found 2. How many are left? 2 more. So this becomes x squared minus x plus 1. What multiplies to 1 that adds to -1? Nothing. There's nothing there that will do that. So I'm going to go ahead and use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, b, c. So negative 1 plus or minus the square root of b squared, so -1 squared minus 4 times 1 times 1 all over 2 times 1. Now I'm going to look here first, because if this does not work, if that gives me an imaginary number, then there's no point in me continuing. So when I add and multiply and I have 1 minus 4, well, that's -3. That's going to be imaginary. That's my two imaginary solutions. So 2 real, 2 imaginary. So my solutions were -2 and -3. The real ones. We're not worried about the imaginary for today. All right. Last example is moving on to graphing polynomial functions. We are wanting to use everything that we just did in order to solve for my x-intercepts. So I'm going to look back here because that looks really familiar. Did we do that one yet? We did. We did that one in 45. And in 45, what did we get for solutions? Let me double check that it was 45. X cubed plus 2x squared minus 5x minus 6. Okay. Oh, that's why I have the 45 there. Okay, so it's the same in your homework, you guys. You're going to solve them, and then you're going to graph them. You're going to solve them, and then you're going to graph them. So if I go back here, what were my solutions? -3, -1, and 2. So I don't want to go through and find those again. So we got -3, -1, and 2. Now let's talk about their multiplicities. How many solutions were there supposed to be? 3 solutions. And how many solutions do I have? 3. So if I put those back as factors, this is x plus 3, x plus 1, and x minus 2. They each have a multiplicity of 1. They only occur once. And odds cross, evens touch. Cross, cross, cross. So when I make my coordinate plane here, just a really rough sketch is what I'm going to do. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So I'm going to plot my x-intercepts. -3, -1, and 2. What am I missing? Oh, my y-intercept. So my y-intercept is -6. 1, 2, 3, 4, 5, 6. Somewhere down here. This is a cubic function because the degree is 3, power function is x cubed. That means my cubic graph is going to look something like this. So it has to cross through each intercept and get down to -6. So it's got to cross, go back down, touch at -6, cross back up. This is a rough sketch, very rough sketch, but it's just now taking your solutions we've solved. I can go ahead and create a rough sketch on the graph. So nothing too fancy. Look back at your guys's work that we've been doing with the polynomials and identifying the analysis of them, their x-intercepts, the y-intercept, the multiplicity, odds cross, even touch. What does it look like? What is the degree? What is the power function? What type of function is this? So make sure you guys look at all of that stuff from your polynomials part in 4.1 through 4.3. All right, that wraps up 4.5. Any questions you have, please ask. You're going to do a lot of work with that synthetic division, so be willing to do that. And I will see you tomorrow with questions.